morning to all of you. Today, Dr. Tapan is with us. Dr. Tapan is in AIRI, New Delhi. He is a scientist there. So he will deliver a lecture on this training program. I think that impact of climate change on solar energies. So please interact with Dr. Tapan.
Everyone, as my friend Yogesh Pandey already introduced me, and I will share my experience and whatever I learned or whatever I have gained regarding the application of voltaic means photovoltaic system in agriculture, and what are the challenges and what opportunity in Indian prospect as well as in global prospect. So, if you start from the, you can see that solar is the source of energy. You can say about in Earth, and in the mythology also it has been described. You can say in Hindu religions they worship sun as a god. So it signifies that it signifies that it is a source of energy, and day and night is decided by the sun only. So you can see in the prospect of energy sources, see the sun is the maximum energy in the Earth system. Then second, coal, petroleum, natural gas, then uranium, wind, hydro, and geothermal. These are the sources of energy. And first of all, or mostly we use solar energy directly or indirectly. Like today we are having a sunny day. Then you might have seen that the temperature from the morning it rises up, and you are feeling the heatness of that. That means indirectly we are feeling the solar energy. That is one way or other. Okay. So if you see the solar energy in how the solar energy is dissipating from the source to the while it is reaching to the earth, you will see that only some part of the energy only reach to the earth. Before that, it get reflected and absorbed by the atmosphere, absorbed by the clouds, and after that also we use most or least amount of the solar energy for our efficiently. So that way, and there are ample of systems are being developed for using that. So if you see the potential of photovoltaic system or solar power energy, India is lying on that category of 153 this kilowatt hours per annum, or in daily basis it will be around 4.2. Okay, that means it is not less, or this is not much higher. So if you see the African countries, it is very high, but it is intolerable, you can say. For living also it will be very harsh conditions. But in India, in the both way, it is win-win conditions. We can use the solar energy for our other purposes as well as for our living conditions also better than that of other countries. Okay, as a human being, we live in the environment, or you can say our main food is from the agriculture, that is related to photosynthesis. We obtain the energy from the photosynthesis, and this is the simple way how the solar energy being trapped and produce energy, and it comes to our food chain, and we get the energy directly or indirectly from the sun. Okay, that's why, and you can see that the efficiency of this photosynthesis utilization of energy, solar energy, is very less in comparison to you can say solar photovoltaic system or all these things. But it is the main source of energy for a human being, but it is least efficient. Okay, and that too, if you see the spectrum sense of the wavelength of the light, only the plant can use this 400 to 700 nanometers. Okay, that is photosynthetic radiations, that is. Okay. Another part is voltaic. Why I am introducing these two things? One is photosynthesis, we require light, and another is solar, and another is we require photovoltaic system, also you need solar energy. That way, solar energy, how the solar energy, this is one simple example how the electrons move from the higher to the lower, and that movement of that electrons get activated, or excitation of the energy means that is trapped as a energy, or it can be photovoltaic energy in solar cell, that is being used. And you can see solar conversion system there. Here any solar cell you will find all these components. There is a cover of glasses or something that is to protect, and then there will be anti-reflective coating, then adhesive, then you will find the semiconductors, which electrons, in terms of electrons and holes, that transfer from one other to other, and that jumping of the, or you can say movement of the electrons get transferred in photovoltaic cell, and that transfer energy. And it is given, you can see the solar photovoltaic cell efficiency is now ranges from 18 to 22%, and solar participation, that means photosynthesis, it is around 1%, but maximum you can find in sugarcane with 3.5%. That means the least efficient but more use is our this photosynthesis. Okay. Now you can see that with the advancement of the this technology, the solar cell being promoted from the changing from the first generation to fourth generation. Earlier, we are mostly on the monochromatic crystalline silicon type solar cell being used, then polycrystalline. Then we shift to the second generation solar cells, that being of film of silicon, and that reduce the thinness of the solar cell by using of cadmium telluride thin films. And then now we are using dye-sensitized solar cells, that is third generation. And fourth generation, we are now using that you can say composite material out of nanoparticles as well as silicons. That way the generation, or you can say the solar cells advancement is going on, and since our domain is related to agriculture engineering, we are not actively involved on that development of that, but we are mostly concentrating on our focus on the use of that solar cell and solar energy system in our agriculture. Okay. Now come to the agrivoltaic. You might have heard about the agrivoltaic system in your curriculum, also in your studies. Agri is related to agriculture, and voltaic is related to solar energy that is being converted into electricity. Okay, so two concepts early. What government approach was also earlier, that when there is a barren land or something else, there they are promoting the installation of large scale of these photovoltaic cells, and such a way that next operations or different operations can be done inside that greenhouse, means that field. Okay.
Sir, I have a question regarding this. One of my students, I was guiding him during when that student was in his master's. He was doing research on agrivoltaic in MET University, Delhi. So during her results, what we have seen that they have taken two crops. One was under the shading of these photovoltaic panels. There was a size reduction in tomatoes and also the leaf size. That's what we have seen.
Everywhere you cannot fix the this agrivoltaic system. When you are selecting agrivoltaic, it means you have to select the crop which are shade lobbing, and that can be grown. That's why there are the different experiments. I will give you one example of that. I will in the last I will describe of the what are the crops being grown and what are the means outcome. That I will show you. Okay, that will clarify you why that is happening. And you know that I given one this spectrum of light now where PAR I was discussing about it. Yes. Photosynthetic active radiations. That means the crop requirement are different. Okay, different crop are requirement having different requirement. So if some crop are shade loving, then that can be grown under that. And I will show you that. Okay, I am just coming to the next. मैं तो अभी introduce ही कर रहा था. I was introducing the subject to you rather than then I will come to that. One example also I will give and also design of that. Okay, so agrivoltaic system is consisting of these all. And your agriculture, if land is productive, is poor, then we may recommend that agrivoltaic systems, or no, then purely agriculture. Now another way, if it is environmental hazardous PV generations, then we go for agrivoltaic, or we recommend for that. And both way we can have this win-win situation when we combine this both. In the conditions like Jodhpur, you might have Kajri you might have heard, and in that conditions the first agrivoltaic system is installed in Kajri, okay, 20, 30 or 20 years back, okay, and that location was suiting or soothing to that because of the climatic conditions of that and as well as solar radiations of that, okay. So that also I will include on this, including my study. So why we are going for agrivoltaic system? The advantage is solar energy is maximized, and this cultivation of some crops due to shade effect, that shade loving crop can be grown. Then increase the land productivity based on mutual common use and favorable environmental impact. And you can see the agrivoltaic system increases the global land productivity. How does it increase the land productivity? Because of this crop residue, it is. I will give in detail of that also. And the both way that it benefited the economic benefits having due to use of land use efficiency. Then it also enhance the water use efficiency by 25 to 30% because of that restrict the shade and temperature around that crop canopy area, and it also enhance the photovoltaic efficiency of that photovoltaic system because of that one of the major constraint in the photovoltaic system is temperature. When temperature rises, then the efficiency of the photovoltaic system reduces. That's why this plant, if you grow the plant near to that reduces the temperature around the photovoltaic system. So then biodiversity enhancement is there in the photovoltaic system. Why we need the photovoltaic system? Where now we are both the demand of food as well as energy. Okay, that's why in our if you see that projection by 2050 the energy requirement will increase by 50% and food requirement also increases like that way. So both the cases can be compensated by this agrivoltaic system. That's why it is being promoted now. And in case of Indian prospect, you can see our aim, जो SDG goal बोलते हैं ना, जो our aim is to reduce or zero emissions by 2050. That can be only achieved by adopting the solar or renewable energy, and not other than that. Okay, and we are predicting that 25 of electricity needed will be from solar photovoltaic system. And renewable energy means it will include all the bioenergy and all this, but I am talking about 25% means it is related to solar photovoltaic system only. Then our food requirement also will get increased. That's why this will, the photovoltaic system will both win-win situation for both energy as well as, these are the some statistics related to energy requirement, how energy requirement of India will also go increase along with our global demand. And if you see the scenario of this requirement, if constrained renewable energy conditions, unconstrained renewable energy conditions, and non-fossil fuel scenario conditions. In both the conditions, the renewable energy growth will be increased in 3 capacity. So, if it is constrained conditions, then it will increase slowly, but it will be in non-fossil fossil fuel requirement, then condition will rise, then certainly it will increase in the where the region you are having fertile lands. That means agrivoltaic system will be enhanced. So it is the condition for that. The current status of solar energy, you might have having the idea about that. By our target was by 2022 175 gigahertz, but still now we have not achieved that. And now India is ranked now 4th total installation in solar energy, overtaking Germany. But our potential is much more higher than that of what we achieved. And there are different, you can see about the different programs is run by the government of India for promoting the solar photovoltaic system. The one is, you might have heard about Kusum. Have you heard?
Yes, sir.
आपको तो बोला गया था शायद last class, last lectures. And that installation is about 3.62 contributor, and overall installation capacity is 2.96 gigawatt. Now ground mounted solar installation dominate 80%, means the mostly it is being the mounted type, where the regions barren lands are there in large area, that is being done. And this Kusum is mainly for off-grid system, and that is in smaller size in comparison to that of the. And now government is promoting rooftop solar installation system also. Now, different type of this agrivoltaic system being used in that. One is elevated system, you can see that. Then ground mounted system, vertical system, and dynamic tracking system, dynamic or tracking system that you can see by one. Here, so you can see that one is, this is the vertical system, and these are the different systems being used at different height as well as different spacing. Then depending upon the crop requirements, the spacing is being decided, and all the cases they are mounting is done at different angle of that requirement of the solar panels, and some are tracking. You can see about the tracking system. This you can see the single axle photovoltaic system of tracking modules with the tracking modules, and dual axis solar tracker. That means it can move in both the directions depending upon the solar position in the radiations or in the day. Okay, and you can find that this is the high rise of this solar panel system, where the tractor can move and the operation can be done by the farm powers available on that. Then another is vertical type of this solar photovoltaic mounted system, where the solar panels are mounted in both the directions. That is bifacial system. Okay, so in that way, you can see about the elevated system. Dynamic tracking system is that changes degree of the solar panel can be changed for optimizing the solar energy. and then vertical system, in both ways it is used for tracking the solar energy. These are the main classification of the solar photovoltaic system. Then you can see the open agrivoltaic system, interspace, then overhead, that I have shown you already, fixed single axis and dual axis, that is means double tracking system. And then the permanent grasslands, arable lands and horticulture crops, depending on the food requirement, animal feed or staple food or fruits and vegetables. Then grazing, annual crop, perennial crop, that way it is classified. The whole agrivoltaic system can be classified like this. Okay. And some of the agrivoltaic system is being used in the greenhouses, that is protected cultivations also. Now, why do we say that photovoltaic system is more efficient than energy land use efficiency is more? Because it can grow both energy and as well as the crop. And if you see that in case of agrivoltaic means agroforestry system also, this land equivalent ratio is being used for calculating the land use efficiency of the crop. So that same formula, or you can say same thing, is being used for calculating the land equivalent ratio of this photovoltaic system. And there you can find that the solar farm with agrivoltaic system and only a controlled plot means not having any agrivoltaic systems. Another one is having that of photovoltaics, and another without having any interventions. That way, these are the four stages being given, and it was found that this land use efficiency of this agrivoltaics is 1.4 times more than that of having any photovoltaic system, either photovoltaic system or only crop. So both, if you combine that, it will be economically viable, and as well as energy wise also and crop wise also it is viable. So if you take the this solar components, you will find that one is solar infrastructures that you require, that is solar bifacial solar panel when it is in case of this vertical system. Then transparent panels are there. Then standard modules are being used. And if you see the efficiency of that, in case of vertical panels, the yield may be increased, but in case of the transparent, the efficiency or solar efficiency or energy efficiency of the photovoltaic system are more in comparison with the standard modules. Then the mounting of the photovoltaic system are one of the important components of that. One is fixed mounting that being used, and dynamic mounting. The dynamic mounting is used for when it has to be give the direction of the solar module with the day of the sun means position of the sun on the day. So along with that, irrigation system, we are using solar sensors, auto control system, weather link, and flow meters are being used for irrigating or smart irrigations. And the compatible crop management, what you are being asked is shade tolerant plant, then height adaptable plants and climatic suitable plants. These are the criteria for selection of the crop. Then crop yield tracking, then growth metrics. These are the crop management system is to be adopted for agrivoltaic systems. If you see the system along with that management system, you require electrical system and monitoring system. In case of this agriculture system, we have to monitor the soil moistures, climatic conditions, and yield monitors are being used. And in case of the electrical system, inverters, that is for tracking the energy and transporting it to our transmitting it to the grid. Then power optimizers and monitoring system being used for optimizing the power of the solar photovoltaic system. What is the crop requirement in based on the what is the now we will solar light available, then partial shade, then shade tolerant crops. Depending upon that, we have to decide the crop. And now primary facing or primarily the south these solar panels are faced towards south, southwest करते हैं. Okay, and that is the one of the criteria. Then the angle, tilt angle is depending upon the कितना होना चाहिए?
About 17 to 20.
25 is optimum, depending upon the location.
Yeah, depending upon the altitudes it decided. Then seasonal adjustment we have to make, that is 10 plus or minus 10. Then light penetration optimization. Then the orientation is deviation allowed. This deviation south facing or southwest facing. Then depending upon the clearance of the or tractor height, the clearance is decided. Turning radius. Then water requirement, rainfall in the patterns, panel runoff, and the irrigation. That decides the your spacing of the panels, height of the panels, and all about that. Now the design criteria. What I was asking to about you that what should be the inclination or you can say angle of that, and you can see zenith angle, azimuth angles, and the elevations will decide your angles of the panels and height. Depending upon your requirement of the height, the movement of the vehicles or the pump vehicles, you have to decide the height of that. Then angles and the spacing of the two panels, depending such that the shades of the one panel should not fall on the other one, and this depending on the crop requirements, decide that. Okay. So only one example I have taken. It is the solar panel layout at Kazri, Jodhpur. Okay, you can see that the total area is of 60 meter into 60 meters, and there are 3 blocks are there. The solar arrangement are of 3 types. Okay, solar arrangement are of 3 types. You can see about block 3. There are 2 panel means lines of that. Then in block 3 block 2 you will find 3. Then block 1 you will find 6. Okay, so and the voltaic systems are being given. You can see about the 3 ones. And the total capacity of this plant is about 115 kilowatt or 105 kilowatt. Okay, that means they are this system is attached with the grid. Okay, and they are generating power, and also they are having their transformer that is located, because the location of transformer should be so optimized that there should be minimum loss in the transmissions. Okay, that you can see how all things been designed. Okay. Now the panels array are being arranged. You can see about that in block 3, the size of the panels and the height. You can see at the block 2 and block 1 are different in different conditions are there, and the interspace utilization efficiency, or you can say, is 49% of total area, and below the panels in only 24% of the installation area is available. Means maximum area, interspace area is 49% is available for cropping, and below panels some crop are grown that are that is shade loving crops. So this is the whole system. You can see about the photovoltaic system is available in Kazari. Okay. So they are growing, and this is the real. If you ever get time or chance, then visit this. It is available still now, and it is working fine. Okay. And they are using this water, having water harvesting structures along with the solar panels, so that it cleans the solar panels, as well as the same water being harvested in a place, and that is being used for irrigation of the crop. Okay, so this, you can say it is about it generates about 420 unit of electricity per day, and approximately you can see 7 to 8 lakhs per acre per year they are getting out of this. Okay, this is the and also they are growing crop along with that, and different crop being grown in this agrivoltaic systems are mung bean, isabgol, cumin, okay, then eggplant, and they also have written about that eggplant was significantly affected by shed. Okay, and the performance of the mung bean is good in comparison to other crops, and isabgols and cumins also significantly affected by that. Now they are recently they are now adopting this aloe vera. It is working very fine, and the crop is good in these conditions. Aloe vera can be grown under this photovoltaic system. Okay. And this is the rain water harvesting structure, which is being constructed on that. So they during the rainy seasons and you know that it is Kazir is on arid regions, so very limited rainfall is there in that regions, and the water which is being received during the rainy seasons are collected at and being used as irrigation. Okay. If you see the land equivalent ratio of agrivoltaic system in the which is being used in Kazri, then you will find that it is 1.41, and the total area of that is about 1 hectare. On the basis of that, you can find that the investment is around 2 crore for installing agrivoltaic system at 1 hectare, and that is, and maintenance cost is around 1 lakh. Then replacement cost is about 30 lakhs, but per annual income is also, it is net present value of discount means after discount rate is 60 lakhs. Okay, so in that way it is one kind of viable or economically viable conditions for growing this crop under agrivoltaic system. So some salient points are given here. The agrivoltaic system that it collects about 1.5 lakhs water, and microclimatic conditions of the optimized. Then soil erosion can be reduced, and dust load on the panels also get reduced, and land use efficiency increased by 1.41 times. Then soil moisture conservation is taking place. Then it also reduces the greenhouse gas emissions. There are some challenges along with the agrivoltaic system. One is safety of the field workers engaged in the agricultural activity. Then the manager who is running that agrivoltaic system should have some knowledge about the agriculture as well as agrivoltaic system. Then if you install it in the farmer's field, then some working module has to be developed so that the farmers can have get the benefit as well as share of the responsibility. Then high capital investment is required for installation of the solar photovoltaic system. But in India, you might have heard about GIZ. Have you heard about GIZ? You can search about GIZ, write it down. And now one of the German entrepreneurship, they are involved in development of this agrivoltaic system in India. Okay, and their target is very huge, and it is in collaboration with the government. They are doing that, and they have already installed some of the 100 kilowatt or 1 gigawatt power plant in all over India. So they are in Jalgaon, Maharashtra. Some are in eastern states, and recently they are now in going MOU with AIRI for installation of Center of Excellence on Agrivoltaic System. Okay, and so government initiative also there for starting this agrivoltaic system in India in large way. So these are the trends being used in agrivoltaic system, like single axis tracking, dynamic systems, fixed structures. However, if you see now present context, 65% are now under fixed conditions. Okay, and then a smart control system, then IoT integration system now being used in the photovoltaic. These are the management software being used in the photovoltaic system, and global market view, you can see that it will now prediction that by 2030 it will be having the global share of $9.7 billion. In regional distribution, you will find in Asia and specific region it will be 35% in world prospect. So it is one of the, you can say, leading or one of the important avenue for agrivoltaic system ecosystem. Now, already I mentioned about that 9.7 billion it will projected for dynamic marketing, and in India it is already Asia specific case. You can say Japan is well ahead of us, China, and now India is on 6% only. Okay. So my topic is related to climate change associated with that agrivoltaic systems. So if you see the lifespan of the agrivoltaic system is about 25 years. By system efficiency get reduced with 1 degree of rise in temperatures, and this material degradations, increase in irrigation demands, crop adoption requirements are the challenges before due to the climatic or changing in the temperature or climatic scenario of these agriculture sectors. Now, this climatic change not only affect the agriculture but also in photovoltaic systems. Due to that, depending upon the climatic condition only, the photovoltaic conversion efficiency depends. That's why it will affect by the climate change parameters, and starting from the atmospheric changes, system performance changes, then agriculture impacts that is being given. So you can see that atmospheric changes means carbon dioxide level increasing, that affect the plant growth. Then precipitation changes. Sometimes you will get more precipitation, flood condition will occur, and sometimes you may have no precipitation, means drought conditions. Then atmospheric pollutions also impact this crop as well as this photovoltaic conversion system. Then heat induced efficiency that induce the efficiency of the solar photovoltaic system. Material degradation takes place due to the climatic change in the photovoltaic system. Power out fluctuations will there due to that solar intensity fluctuations, and lifespan also get reduced. In that way, this all get affected by the climate change in photovoltaic system, agriculture as well as photovoltaic conditions. Now then the adaptation strategy, what are the strategies being used? You have to have technical adaptations and as well as agricultural adaptations. So we have to get more smart technology related to irrigation to save the water, because in future water should be will be one of the most scarce commodity for agriculture. So water saving should be made up to 40%. Then that may cost per acre basis $180 per acre, but it will return within 2.2 years. The climate resilience crops, you have to adopt some crops which are more resilient to resistant to abiotic stresses, and that may also cost more, but it will you can get it within the 2 years. So smart monitoring system that will enhance that. So these are the technical adaptations and our agricultural adaptation system that with the changing scenario we have to adapt for agrivoltaic system. Now the solutions being given: reduce ground temperatures, heat stress production crop, then water conservation technologies has to be adopted, then temperature stress tolerant, and that crop will impact. When the temperature rises, then crop will get yield will reduce. That scenario will occur. That's why we have to go for abiotic stress tolerant crops. Now climate mitigation challenges and conservation efficiency. Now biodiversity, by this agrivoltaic system, your biodiversity will increase, and water saving, you can go save the water because of the reduce the evapotranspiration losses by the photovoltaic system, and then there will be low carbon emissions due to the photovoltaic system, and it will soil carbon storage will get enhanced. Then this carbon emission reduction 45 tons per acre per year can be achieved by this photovoltaic system. That way the photovoltaic system not only economically viable but also environmentally sustainable conditions that will definitely help the farmers as well as the ecosystem for long run. Now Indian agrivoltaic initiatives by the government of India, what the target capacity about now the government has given the target capacity of 30.8 gigawatt, and that to central support of 34,000 crore, and the financial means assistance will be from 40% from the central financial assistance, and rest of the assistance to be taken by the other parts, means 60% has to be from the entrepreneur. So in Gujarat you will find Maharashtra and Karnataka, they are leading in this agrivoltaic system, and as well as they are per acre or about 27,000 they are is being reported for getting from the agrivoltaic system. Now farmers now about 3.5 lakhs farmers are being benefited by the agrivoltaic systems, and it is running at 15 states, and the enhancement of the income by the farmers raised up to 60%. Then there is chance of enhancing the rural development generations, energy security for the farmers because of the energy being used in the farm itself. Then it have the economic benefits because it gives about 27,000 per month income to the farmers, and sometimes it enhances the yield by 32%, depending upon the choosing the right crop to be grown under the said conditions. And also it reduces the emissions and consumes the water by 40%, and land use efficiency, I already mentioned, the land use efficiency certainly increases in case of a photovoltaic system in comparison to the conventional system. Then, so for a way forward is that it should be scalable, innovative ideas should be incorporated in the agrivoltaic system, and there should be a collaboration between central government as well as the entrepreneur and the industry for promoting this. Then it will certainly empower the farming community to have the energy in their farm and have the crop in a same field. So some crop I was discussing about that. Some crop been there have been reported from different countries that you may see that wheat is being grown under agrivoltaic conditions, and reported that reduction in dry matter by 11 to 29%, and reduction in yield you will find it to 8 to 11%. That means certainly it reduces that. However, in terms of this land use efficiency, it will more. And lettuce is being grown, cucumber. You can see reduction in evapotranspiration means that is irrigation is reduced. Crop cover was significantly higher. This means lettuce can be grown in the these agrivoltaic systems. Then come to the other crops: wheat, rice, potato, then soybean. So these are different crop being grown in different agroclimatic conditions, and it has been reported that sometimes there is this reduction of the yield and biomass, but certainly it will help in overall conditions. The economical condition will not be get hampered by this agrivoltaic system. Thank you.
And what will happen to the solar panels? Like it will go into waste. So
If there are now government is giving the guidelines for recycling of these materials, and some program is now being in project mode. They are working on biodegradation of this. Now, that's why I shown you that one of the slides that now instead of this crystalline and polycrystalline, then shifted towards now fourth generation, this composite materials. Now the material also some kind of biomaterial being used for photovoltaic generation of this. One of my slides I have given you that. कैसे स्लाइड करना है? पीछे ऐसे ही जाना पड़ेगा. Second or third slide? Yes. See, organic now solar cell being used. That was one of the challenge you have rightly said that. One of the challenge for in long run how to recycle that, because it is having silicon and all the chemicals or heavy materials along with that crystalline structures. So now the solar cell being manufactured from different composite materials. Now it is, you can see about some composite material being used for development of this. Okay. Composite material out of that, zinc. Then here you will find organic solar cells being used. So different material being used instead of silicon and other things. Okay.
Obviously, there will be yield will be low, but if we see the economical value, he will be in a win-win situation because he will be selling his these vegetables and also fruits or vegetables and also the electricity. Under this Kusum scheme, is there any provision given by the government, the central government or the state government, that the electricity that has been generated from these agrivoltaics, they will be buying?
Yes. In Kusum, there is a provision that the electricity generated by this agrivoltaic or any power station, it will be purchased on 4 rupees per unit.
And is there any limit that the agrivoltaic should be this much capacity, then only they will be selling it, or it can be?
There is a restriction over that. Below that, they cannot have economic means install all the transformer, all things has to be installed for connecting with the grid. That's why some condition is there. So we have to minimize, have the minimum of that much of power to connect it with the grid. उससे कम होगा तो नहीं, it no chance of getting connection from that.
Any more question? Thank you, Dr. Tapan, for a very good lecture. Now, there is provision to give a memento to our guest lecturer. So please take it.